All right, so we're using the data to estimate f prime of 2.25, which just means we need to find the average rate of change on that interval. So that ought to be 10 minus 6 over 2.5 minus 2, which is 4 over a half, which is 8. And it says using correct units. So what were your units for that? Yeah, it's milligrams per centimeter squared per centimeter, because we're taking the derivative of the milligrams per square centimeter with respect to R, right? So if you want to write as milligrams per centimeter cubed, that's fine. Milligrams per centimeter squared per centimeter is also fine. Either way is good. And if we're interpreting the meaning of that, what is the meaning of this thing? It's just the rate of change of the density, right? We would say that the rate of change of the density is 8. I mean, yeah, you write it down words however you want, but the rate of change of the density. And I can't give you guys, I know, was it? Yeah, just Kevin, right? Is the only one that took it. So I couldn't tell you what the point values for each question were worth. So they haven't released the scoring guidelines, but I bet you got that right. All right, part B. Total mass is this integral 2 pi times the integral from 0 to 4 of r times f of r. We want to approximate that integral using a right Riemann sum with 4 subintervals. So that should be what? 2 pi times, and then if we're doing a right Riemann sum, we're going to go from 4 to 2.5, so that's going to be 1.5. And then what is r times f of r? That ought to be 4 times 18. Everybody get? Yeah, from 4 to 2.5. That's 1.5. 1.5. Oh yeah, I mean you could have started here and done this one. I always go right to left. If it's a right Riemann sum. I don't know why, doesn't matter. Next one is a half. And what is r f of r this time? Should be 25. R f of r, 2.5 times 10. Next one should be 1 times r f of r is 12. And then the last one should be 1 times r f of r is 2. And what did that come out to be? Does that sound good to people? 845.088. There, you missed that. Jenna? Anybody agree with Ben? Zoom. Did any of you get that value? You all did this yesterday. You had 74 minutes to complete these 6 problems, plus whatever time you needed afterwards. Did you get 845.088?
No, but I think I got it wrong. So.
Did anybody get that value? Ben is sitting here nervously wondering if that's the right value. Kevin, is that the value you got when you took the AP test?
What?
Is that the value you got when you took the AP test?
I'm pretty sure they gave different forms with different questions.
Yeah, you might have had a different form. This was like the main one that they had, but you might have got a different form. All right. Jenna and Derek said that's what they got. All right, we'll go with that. Good. That's supposed to be a star. It's not. There we go. All right. Part C, is the approximation found in part B an overestimate or an underestimate of the total mass of the bacteria in the Petri dish? So How do we know if it's an over or underestimate? Well, it's a right Riemann sum, so if the function is increasing, it should be an overestimate. And we know that f of r is increasing because it says it is. And r times f of r, well, r is getting bigger and f of r is getting bigger. So if both things are getting bigger, that must be increasing. We'll say r f of r is increasing. And so a right rectangular approximation is an overestimate. Good or no? Yeah. Wonderful. All right, part D. The density is modeled by the function g for 1 to 4, where g of r is 2 minus 16 times the cosine of 1.57 times the square root of r cubed. We want to know for what value of k from 1 to 4 is g of k equal to the average value. So if we want g of k to equal the average value, we need to find the average value. How do we find the average value of a continuous function? The integral with 1 over b minus a in front of it. So we want 1 over 4 minus 1 times the integral from 1 to 4 of g of r dr. And we want to figure out when that is equal, when the average value is equal to the actual value. Well, what's the actual value? It's g of k. So you would have figured out what this value, what was the integral from 1 to 4, 1/3 of the integral from 1 to 4 of g? And then set that equal to the function g of x and see where they intersect. And you know that they're going to intersect on the interval from 1 to 4, right? So you might want to set your window on your graphing calculator to 1 to 4 just to see only those values, but you'll have to. What did you get? That's on the interval from 1 to 4. $497. Anybody agree with 2.497?
Yes.
Yes, wonderful. Any questions on that one? No, if you just wrote this, I think you're probably good. But it doesn't hurt to put that value in. I mean, it just makes it easier to graph it and stuff. All right, everyone's good with number 1? Let's look at number 2. Time t greater than or equal to 0, particle moves in the xy planes with its position of x of t, y of t. Its velocity vector is given as t minus 1 e to the t squared sine of t to the 1.25. And at t equals 0, the particle is at position negative 2, 5. So we want to find the speed of the particle at t equals 1.2. How do we find the speed of a particle? Speed is absolute value of velocity, right? And what is the absolute value of the velocity here? Exactly. So it should just be our square root. Oh, sorry, just for speed, not distance traveled. I was looking at part B. Speed, t minus 1 e to the t squared plus sine of t to the 1.25 squared. And what did that come out to be? People agree with that, 1.271? Yeah. And then to find the acceleration vector, we need to take the derivative of both of those. Right? You take the derivative of this. So what's the derivative of t minus 1 e to the t squared? You got to use the product rule. Yeah. We're looking for the acceleration. Oh, at 1.2. Never mind. We don't need to actually do that. I should read the question. Evaluated at t equals 1.2. What's that derivative? And what's that derivative? Both at 1.2. What'd you get? $405. Everybody agree with that? People at home, are you good with that?
Yeah.
Yep.
All right. Part B, find the total distance traveled. That should be the integral from 0 to 1.2 of our square root of t minus 1 e to the t squared squared. What was it? Sine of and what that come out to be. 1.010. People agree with that? Yeah. Any questions or issues there with part B? How about part C? Finding the coordinates of the point at which the particle is farthest to the left for t greater than or equal to 0, and explain why there is no point at which the particle is farthest to the right for t greater than or equal to 0. So first off, if we're looking at when something is furthest to the right and furthest to the left, what do we have to do with the x coordinate of the velocity vector? And maximizing it, we're looking for when it's equal to 0. So t minus 1 e to the t squared is equal to 0 when t is one. That's the only time, right? E to the t squared will never be 0, but t minus 1 is 0 when t is 1. So t equals 1, and then we're talking about 0 to infinity, so we make a sign chart. Something between 0 and 1, if I plug it in here, the e to the t squared is always positive, right? So that's always going to be a positive value. And then t minus 1 is going to be negative, so that's going to be negative. It's going to be moving to the left. And then greater than 1 is going to be positive, and that's going to be moving to the right. So we move to the left. We hit our furthest leftmost point at t equals 1. And then we start moving back to the right. So we need to figure out our position at t equals 1. We wanted both the x and the y coordinate, right? Coordinates of the point. So our position at t equals 1 ought to be -2 plus the integral of dx dt from 0 to 1. That's our x coordinate. And then our y coordinate, I think it was 5 where it started. Is that right? Yeah. And integral 0 to 1 of dy dt. What would those come out to be? Does that sound good, everybody? Yeah, Derek, you're good with that? People at home, you're good with that?
Yep.
What? Yeah? Is that a yes? All right. Wonderful. All right, part C, right? Explain why there is no point at which the particle is farthest to the right for t greater than or equal to 0. So first off, we only have the one critical value. So the only other time it could be furthest to the right would be at an endpoint, right? And obviously, as t goes towards infinity, this is going towards infinity, right? It's not, it's not like approaching some value, which wouldn't matter anyway, so when we're reaching that point. So we'd have to look at the only other possibility is our endpoint. There we go. as t approaches 0, what are we looking at? The limit as t approaches 0 of, what is it, t minus 1 e to the negative t squared. What does that become? End up with -1 here, right? And this is e to the 0, -1. That just comes out to be -1. To the right. Oh, yeah, okay. So then, yeah, okay. So we're at t equals, we're at t equals -1, and then the limit as t approaches infinity of t minus 1 e to the negative t squared is what? That ought to be, what's that value? This should be going towards e to the negative infinity down here, which means it over e to the infinity, which means it should be going towards 0, right? But if we were at -1 and then we were going towards 0 as we got moved to the right, this is not going to be the furthest point to the right, right? Because this and this, we're not actually hitting this value, and this value couldn't be the furthest, the rightmost point because this point is to the right of it. But we don't actually get to the value of 0 because we're going this as we approach infinity. We don't actually hit 0, we're just approaching the mass. Does that make sense to everybody? So you'd say something to the effect of, you'd say that the only possibility is at t equals 0, where the x coordinate is -1, but as t goes towards infinity, but I don't know, but yeah, I'd say something like, something like that. -1, but we're going back to the right past that. So something to that effect. Is that good or no? Yeah, it's always going, that would work. Yeah. Say that the velocity is always, or the x coordinate of the velocity is always positive. So it's always moving to the right. Always getting bigger. All right. How'd this one go? The first non-calculator one. This was an overlap with AB also. The AB kids were complaining about this one. I'm not sure why. It's pretty straightforward, yeah. I guess we'll find out. So first part is find the area of the region in the first quadrant bounded by the x-axis and the graph of y equals cx root 4 minus x squared for c equals 6. Yes, this was also on the AB test. But it was on both the AB and the BC test. So finding the area just means we need to integrate this from 0 to this other intersection point. What is this other intersection point? We need to figure out when does, we got c equals 6. When does 6x root 4 minus x squared equals 0? That'd be when x is 0 and when x is 2. Everybody go with that? So we'll just integrate from 0 to 2, 6x root 4 minus x squared. Easiest way to do that will probably be just a simple u sub. U equals 4 minus x squared. Du is -2x dx. You've got the 6, which can be broken down into a 2 and a 3. You just need the negatives. So we end up with -3 and then an integral of u to the 1/2 du. And we need to change the limits of integration from 0 to 2. If we plug in 0, we end up with 4 as the lower limit. If we plug in 2, we end up with 0 as our upper limit. Everybody good with that? Cool. All right, and then probably flip your limits of integration to make this 3 times 2/3, use the 3/2 from 0 to 4 instead of 4 to 0. I just did the integration at the same time there, and then plug in your values. What do you get? Plug in 4, that's 8 16/3 times 3 is 16, and then minus the 0. Good or no? Everyone good with that? Yeah. Part B. All right, part B said it is known that for that function, the derivative is equal to that function that they gave us for the derivative. And we know that the radius of the largest cross-sectional circular slice is 1.2 inches. So we want to know what value of C gives us that largest slice of 1.2 inches. So the largest slice would come when that function is at a maximum. And since that function is at a maximum when its derivative is equal to 0, we'll just set the derivative equal to 0, which means we're just going to set the numerator of that derivative equal to 0. To get x equals the square root of 2. Everybody good with that? So now that's the location of where we have this max, and we probably want to show that it's a max, but they gave you the graph. Clearly, it's a max at root 2. If this is 0 and this is 2, I mean, there's no min in there, right? So then we just want this this radius to be 1.2. And so we have to just take our original function, plug in square root of 2 for x, and plug in 1.2 for y to solve for c. So we should end up with 1.2 equals c root 2 root 4 minus x squared, which ends up giving us 1.2 equals, well, let's see here. Root 2 times this is also going to be root 2. Root 2 squared is 2, and 4 minus 2 is 2. So it's root 2 times root 2, which is 2. So you end up with c equals 0.6. Everybody good with that one? People at home, you good? Yeah? Y'all are good here? I think you were right. It's going to be after 10:20 when Noah gets here. Yeah. If he decides to show up at all. I believe it's the 11th grade English AP language test today, so that'd be weird. All right, part C. For another spinning toy, the volume is 2 pi. What is the value of C for that? So the volume, which is 2 pi, needs to be pi times the integral from, what was it, 0 to 2, right? Of C x, cx root 4 minus x squared squared dx, right? Pi radius squared dx integrated from 0 to 2. Everybody good with the setup? Yeah? Cancel out your pi's. We got 2 equals the integral from 0 to 2. This is going to become a c squared, which is just constant. So I'll pull that constant out if I want. C squared x squared or minus x squared dx. So we end up with, I'm just going to have this 2 over c squared is the integral from 0 to 2 of 4x squared minus x to the 4th dx. Everybody good there? And then we got 2 over c squared. This integral is 4/3 x cubed minus x to the 5th over 5. From 0 to 2 gives us 2 over c squared. And if we plug in 2 to this, what do we have? 32/3 minus 32/5. Yeah. What's 32/3 minus 32? fifths, 64/15. And what is that, 30/64? So root 30/8. Sound good to everybody? Yeah. People at home, you good with that one?
Good.
So yes?
Yep.
Great. Anybody, any questions? All good. So you want to graph what? Yeah. Sure. Yeah, we can grab it. Let's see. What was the no, you're talking about the problem before, right? You're talking about the problem before. So Ben wanted to look at the graph of the velocity vector here. So from that previous one. So it was t minus 1, right? E to the t squared or negative? Oh, it's either t squared? Oh, I think I wrote negative t squared in there somewhere, didn't I? I think I did. I did, didn't I? I wrote a negative t squared there? Yeah. Oh, I wrote negative t squared for both of these. Oh. Those should have both been positive t squared. Not that it changes the first one. But this one was t squared. That's not. This isn't. Infinity. Anyway, that's better now. Now that I've got the right value in there. Now that I have the right actual velocity vector. So yeah, the velocity is getting very, very large, increasing to infinity. Anyway, sorry. What was the y coordinate of that? Oh. I mean, this is your velocity, so your x values are good. Yeah, I don't know why I wrote those as negative t squareds. How come nobody told me I wrote those as negative t squareds as we were going through there? Nope. I just wrote it because it was on the previous page. I didn't go back to look at it. Kevin, they didn't. They released the questions. Well, so they released the form that most people got from the May 4th, but not the solutions to them. They just released the problems, but it's only like they give like 7 different versions, but most people get the same version. So they released the 6 free responses of the version that most people got. You may have got a different one. So if you didn't recognize all 3 of those problems, you got a different version. They're all on the College Board website, but they have not put up. It doesn't say. I don't know what version letter it would have been. It varies from year to year, I believe, which one is the one that most people get. And it doesn't say online which version it was. So. Okay. So since we're having the graph one tomorrow, no, it's fine. Tomorrow's Thursday, right? So we're having the graph quiz on Friday. We can take a look at the next couple of graph problems, maybe. Yeah, I believe form M is a non-standard one usually. It's usually not the one most people get. I think they use like A, B, M, O. I don't even know. They don't use all the letters, but M is usually, I don't believe, the one that most people get. Let's see, we did this one, right? Did we do this one? No? Did we do this one? Did we do this one? Yes. So this one. All right. Have you guys done these or do you need time to work on them? What? You have? Have not. Okay. All right. All right. So let's see. What time do we actually get out here? 11:27, right? Okay. I'm gonna give you guys just like 10 to 12 minutes. So hopefully we can get through 2 different problems maybe. I feel like you guys are pretty, if that's not enough time, then I can give you extra. I'll set a timer for 12 and we'll see. We'll see how it goes. You still need the extra 3 minutes, that's fine. Y'all at home can see that, right? I shared the right screen with like the triangle looking things. Perfect. All right, ready to go. First off, we'll note that these are all linear. All these little pieces are linear. And that g is the integral from 2 to x of this function that's been graphed. So we want to know, does g have a min, max, or neither at 10? So first off, we'll have to recognize that g prime is equal to f, right? And so if we want to know when g has a min or a max, or if there is one at 10, we need to see if it changes signs. So the question is, does f change signs at 10? And the answer is no. Right? It's equal to 0, right? But it's a critical value, but there's no sign change, and so therefore it does not have either a max or a min as an either. Everybody go with that? People in the Zoom, you go with that?
Good.
All right. Does g have a point of inflection at 4? So now we're going to look at g double prime, which is f prime. So the question then is, does f prime change signs at 4? Well, f prime, slope of this, goes from positive slope to a negative slope. So answer should be, oh, it's not at 10. We're looking at 4. Sorry. At 4, it goes from a positive slope to a negative slope. So yes, still. We'd agree with that? Everyone's good with that? You good with that, Derek? It is not differentiable. That's true. That's okay. Yeah, important point. Remember that change in f prime slopes from positive to negative. It's okay if the derivative or if the second derivative is not defined, right? That's okay, as long as there's still a sign change. That's what matters. As long as the function itself, g, is defined at 4, which g is defined at 4. G is the integral from 2 to 4. Right, so that's fine. The function itself is defined at 4 as long as its second derivative changes. Everybody good there? Cool. All right. Let's see here. Part C. Find the absolute min and the absolute max of g on -4 to 12. So we need to check endpoints, and we need to check any place where the function crosses through the x-axis. So that'd be -2, not at 2 because it doesn't cross through, 6, and then not at 10 because it doesn't cross through. Everybody good there? All right. So we need to find g of -4, which is the integral from 2 to -4, or we could say the opposite of the integral from -4 to 2 of f. which should be the opposite of, let's see here, and let's make our lives a little bit easier here. We're gonna have to find, I mean, we're going from -4 to 12, right? So we're gonna have to find the values of each of these pieces underneath. So what is this one? 4, and this one, this one, this one, and this one. 4. All right, so from -4 to 2 ought to be -4 plus 8, which is 4. So we end up with the opposite of 4, -4. G of, what was the next one we needed? It was -2. All right. So that should be the opposite of the integral from -2 to 2 of f of x. Well, that's -8 based on the picture. And then the next one was g of 6, which should just be the integral from 2 to 6 of f of x. That should be 8. And then we need a g of, what was it, 12 as the endpoint? And so all the way out here at 12, we've got 8 minus another 4 should be -4. Everybody good with those 4 values? And so we would then say that the absolute min is -8, it occurs at -2, and the absolute max is +8, it occurs at 6. Everybody good there? Zoom, are you good?
Zoom, good.
Zoom, good. Wonderful. All right. And then for -4 to 12, find all intervals for which g of x is less than or equal to 0. So let's see here. We started off at g of -4. Our value was -4. And then it became -8, right? By the time we got to 6, though, it was +8. So we were at -4, then we were, -4, and then at -2 we were at -8. And then by the time we got to 2, that's when it became 0, right? Because if we plug in 2 to the integral from 2 to x, that becomes the integral from 2 to 2, which is 0. So we are negative from -4 to 2. And then let's see here, after that, 2 to 6, it becomes 8, right? Positive during all of this. It's still positive during all of this because we're subtracting off those values to get down to 0 once we hit 10, right? At 10, it should be 0. So then from 10 to 12, it's negative again. Does that make sense to everybody?
Do we have to justify it, or can we just write out the intervals?
The intervals are just fine on that one. It doesn't say to justify it, so you're good.
Okay.
If anything, you might want to put in like g of 2 is equal to 0, just to sort of like indicate that that's where you knew it was 0 there, but you don't. I don't even think you really need that.
Okay, thank you.
All right. Anybody else? Any other questions on that one? No. We want to do another one? Yeah. Okay. I don't know. Wait. Yeah. I don't know if we'll have time to go through this one, but we'll at least start it, and we'll see if you guys are done early enough. Ready, go. So for part A, oh, actually, let's write this in here. They give us that the areas of these regions are 9 and 12. And we know that we have horizontal tangents at -1, 1, and at 3. So everywhere where it sort of looks like there is, where it should be -1, 1, and 3, that's where they are. We want to find all x coordinates of which f has a relative max. So f has a max if f prime goes from positive to negative, right? So f prime goes from positive to negative at -2. That's one place. And then it doesn't ever cross back through the x-axis. And we know that we were at a local max here. We went from increasing to decreasing at -2. So this endpoint over here at -3, we were lower than we were at -2. And then over here, we're always decreasing everywhere after that, right? Even, we're at 1, we stop decreasing for a second, right? Just for that instant, and then we continue decreasing. So this is going to continue down here. We're not going to have a max at this endpoint either, because it's always positive. Good? Yeah. So just x equals -2. For part B, we want to know when is f concave down and decreasing. So we want f prime negative, and we want f double prime negative. Right? F prime is negative. Well, f prime is negative from -2 to 1, and then again from 1 to 4. F double prime is negative whenever the slopes of f prime are negative. So we'll say this one is true, -2 to, we'll just say -2 to 4. Even though really 1 is not, it's not at 1. And then f double prime is negative when the slopes are negative, which should be -3 down to -1. And then again from 1 down to 3. Everybody good with that? So then the overlap of those would be -2 to -1. And 1 to 3. Everybody good there? People in Zoom, are you good there?
Good.
Great. Points of inflection for f should occur if f double prime changes signs. So that'd be when does the slope of f prime go from positive to negative or negative to positive? Well, that happens at -1. It goes from negative to positive. It happens at 1. It goes from positive to negative, and it happens at 3. It goes from negative to positive. So -1, 1, and 3. Your explanation would be there's a sign change of the second derivative in all of those places. Good with C? All right. I feel like this one was pretty easy overall, yeah? Part D, given that f of 1 equals 3, write an expression that involves an integral for f, and then find f of 4 and f of -2. So if f of 1 is 3, then f of x ought to be 3 plus the integral from 1 to x of f prime. So there's your integral expression. Right? Don't forget the initial condition to it, that f of 1 is 3. So as we go to the right or to the left, we have to add that 3 in. And then we want to find 4 and -2. So 3 plus the integral from 1 to 4 of f prime. Well, what's the integral from 1 to 4 of f prime? Negative what? I think it was 12, wasn't it? Yeah. 3 plus -12. So that gives us -9. And then for the other one, 3 plus the integral from 1 to -2. Sorry, yeah, -2 of f prime ought to become 3 minus the integral from -2 to 1 of f prime. And the integral from -2 to 1 is -9, right? So that gives us 12. Everybody good with this? We're feeling ready for the graph FRQ quiz on Friday? Cool. So tomorrow we will finish up those last 3 from the 2021 May 4th test, and then we will start looking in more detail about like some, other free response questions besides the graph ones. I feel like we should be pretty good on the graph ones. If you have any other, I mean, if there's a bunch more in here. Like 15 more in here that we didn't do. So feel free to peruse through those as you see fit and do any. If you have questions on them, I can answer those also. I think that's it. If you're Zoom, you can go unless you have questions. Otherwise, See you tomorrow.